Hello students, in our today's session we will see the miscellaneous exercise number 2 of inverse trigonometric function chapter. So in this first is to find the value of cos inverse of cos 13 pi by 6. So we will convert this 13 pi by 6 such that it will take the form of pi plus theta. Only then we can write that cos pi plus theta is equals to cos theta. So first of all, for this 13 pi by 6, we can write it like 12 pi plus pi by 6. So this will be 2 pi plus pi by 6. Now it is in the form of cos 2 pi plus theta. So we can write this cos 2 pi plus pi by 6 equals to pi by 6. So we will get here cos inverse of cos this 2 pi plus pi by 6. So it will be cos inverse of cos pi by 6. Now since this pi by 6 belongs to this 0 to pi, and hence we know that cos inverse of cos x is equals to x only when its range belongs to 0 to pi. Hence from this, since pi by 6 belongs to 0 to pi, we can write cos inverse of cos pi by 6 equals to pi by 6, which is our answer. Next is to find the value of tan inverse of tan 7 pi by 6. We will do the same procedure in this sum also. So we know that tan pi plus theta is equals to tan theta. So we will convert this 7 pi by 6 such that it becomes in this form. So we will make tan of 6 pi plus pi by 6. So it will be 10 pi plus pi by 6. Now we can write this 10 pi plus pi by 6 equals to 10 pi by 6. So ultimately from this we can write tan inverse of 10 pi plus pi by 6, which is equals to tan inverse of 10 pi by 6, which is equals to pi by 6. Since for when we are going with this cos function, we have to consider the 0 to pi interval. In case of tan inverse function, we have to consider the interval of minus pi by 2 to pi by 2. And since this pi by 6 belongs to this minus pi by 2 to pi by 2, hence in case of tan inverse of 10 pi by 6, we can write pi by 6. So our value will be pi by 6. This is example number 3. In this we have to prove that the value of 2 sine inverse of 3 by 5 will be equals to tan inverse of 24 by 7. So suppose first we are shifting this tan to this left hand side. So this equation will become tan of 2 sine inverse of 3 by 5 equals to 24 by 7. Now we will try to make this value equals to 24 by 7. So suppose this sine inverse 3 by 5 is given. So when we are plotting it on this right angle triangle, we will get this theta equals to 3 by 5. And for this Pythagoras theorem, we will get 4 here. So now this sine theta will be 3 by 5 and tan theta will be opposite upon adjacent. So 3 by 4. Now in place of this sine inverse 3 by 5, we are placing the theta. So this will become tan of 2 theta. Now we are placing this tan 2 theta equals to 2 tan theta upon 1 minus tan square theta from this equation, that is tan 2 theta equals to 2 tan theta upon 1 minus tan square theta. Now replacing with this value of tan theta, so it will be 2 into 3 by 4 upon 1 by minus 9 by 16. So solving this, we will get 3 by 2 upon 7 by 16. So on by solving, ultimately we will get 24 by 7. Hence from this we can write this, that tan of 2 sine inverse of 3 by 5 is equals to 24 by 7. Hence 2 of sine inverse of 3 by 5 will be equals to tan inverse of 24 by 7, which is our requirement for this particular solution. Next is example number 4. We have to prove that the value of sine inverse of 8 by 17 plus sine inverse of 3 by 5 will be equals to tan inverse of 77 by 36. So in such kind of examples, we will first assume this value, that is sine inverse of a 8 by 17 equals to a. This sine inverse of 3 by 5 is equals to b. So there will be two right angle triangle. First one is this for angle A. For this would be angle B. Here opposite upon hypotenuse, so 8, 17, and by applying Pythagoras theorem we will get 15 here. For this it would be 3, 5, so here it will be 4. So what we are trying to do, we will first assume this value to be angle A, angle B, and after that we are finding the tan A from this triangle and tan B from this triangle. Then we will apply the logic of tan of A plus B, and ultimately when we are shifting this tan to this right hand side, so it will become A plus B equals to tan inverse of, suppose whatever we are getting, suppose x here, so whatever value of tan inverse of x is given. So finally this will be in this form, that is in place of now A we are placing again sine inverse 8 by 17, in place of B sine inverse 3 by 5, and here on right hand side we are getting tan inverse, which is our requirement. So we will go with this process. First we will assume this sine inverse of 8 by 17 equals to A, sine inverse 3 by 5 equals to B. So from this tan A will be our 8 by 15 and tan B will be 3 by 4. Now we are placing this in equation tan of A plus B. So tan of A plus B will be tan A plus tan B upon 1 minus tan A into tan B. We have taken this from this equation, that is tan A plus B equals to tan A plus tan B upon 1 minus tan A into tan B. Now replacing this value, so we will get 8 by 15 plus 3 by 4 minus 1 upon 8 by 15, 3 by 4. So on taking LCM, the LCM will be 60. So it will become 8 into 4 plus 15 into 3 upon this 15 4 is 60 minus 24. So on solving, we will get 32 plus 45 by 60 minus 24 will be 36. So this 32 plus 45 will be 77 by, ultimately we will get this 77 by 36. Now here we are getting tan of A plus B equals to this 77 plus by 36. Now shifting this tan to the right hand side, we will get A plus B equals to tan inverse of 77 by 36. So this is our right hand side. In place of A, again we are writing this sine inverse of 8 by 17. In place of B, we are writing this sine inverse of 3 by 5. So ultimately this equation I am writing this on this side. In place of A, we are writing sine inverse of 8 by 17. Now B will be sine inverse of 3 by 5. And since A plus B equals to tan inverse of 77 by 36, so tan inverse of 77 by 36, which is our requirement. Next is example number 5. Here we have to prove that the value cos inverse of 4 by 5 plus cos inverse of 12 by 13 is equals to cos inverse of 33 by 65. So it is similar as we discussed in the previous numerical. The only difference is here all the values are given in terms of cos function. So we will use another logic. In previous we applied for this tan function because on the right hand side tan inverse was given, but in this cos inverse given, so we will use another equation. So first of all we will assume this cos inverse 4 by 5 equals to A and this cos inverse 12 by 13 will be equals to B. So from this right angle triangle cos will be adjacent upon hypotenuse, so 4 by 5, and applying this Pythagoras theorem we will get 3 here. For this 12 by 13 for cos inverse 12 by 13, and we will get 5 here by applying Pythagoras theorem. Now we will take all the value, that is suppose cos A will be 4 by 5 and sin A will be this 3 by 5. Similarly for this cos B will be 12 by 13 and sin B will be 5 by 13. Now since here cos inverse is given, so we will take cos A plus B, and equation of cos A plus B will be cos A into cos B minus sin A into sin B. Since from this equation cos A plus B we are getting cos A cos B minus sin A sin B. Now placing all this value we will get cos A will be 4 by 5, cos B will be 12 by 13 minus sin A will be 3 by 5 and sin B will be 5 by 13. So this 13 5s are 65. This will be 12 4s are 48 minus 5 3s are 15. On solving we will get 33 by 65. So cos A plus B is 33 by 65. So A plus B will be equals to cos inverse of 33 by 65. In place of A again replacing this value. So finally it will become cos inverse of 4 by 5 plus cos inverse of 12 by 13 is equals to cos inverse of 33 by 65, which is our required solution for this example.